you on the activity 1, 2, 3, which is on the long-term projection for key climate variables, climate extremes for Vanuatu. And this is a teamwork effort, and there are plenty of people who are working on this, and you already know them earlier. So including myself, Vanessa Round, Alicia, Kim Nguyen, Hamish Ramsey, Tony Rafter, who may not be in yet, and then Marcus Thatcher and Lian Webb. So I'm just presenting on their behalf. So the objective of activity 1 to 3 is basically to develop climate change projection for Vanuatu. Specifically is for the temperature, rainfall, and the extreme. And the extreme here is focusing on extreme temperature, rainfall, and drought. And the last one is we would like to do the tropical cyclone. So initially, the original scope of work is we produce this for national level, but along the line, when we do some workshop feedback and consultation with stakeholder, there is a request that we also produce sub-national projection, in this case for Vanuatu North, Vanuatu Central, and Vanuatu South. So today, I will discuss a few things. First one is just to touch base on some definition so that we will have the same view on a certain term. And then after that, I will show some examples of draft result on the past, present, and future climate. Even though our work is focused on future climate, we also need to learn about past and present just slightly in this case. So I just showing some selected examples. It won't be everything because otherwise it will be full day to talk about that. So this is just a sort of snapshot of what we produced thus far. Some of them already presented in a previous talk, some are new. And then I would like to remind us the potential use of the information that we can produce here. And again, I'm just showing some examples. And then after that, I'm hoping that we can have an initial discussion on the feedback that you have or suggestion or things like that. And then we go to tropical cyclone that Hamish will talk about that specifically. And then we end up with a longer discussion if we have time, because again, we already sort of 15, 20 minutes late. So, okay, so just to start off, in terms of talking about some definition, I just would like to make clarification about the weather and climate, although we all know everything here. Just in case there are people who are not familiar with this term. So when we talk about weather, it is a specific event like a rainstorm or hot day that happens over a few hours or days or weeks. So for example, today's weather in Vanuatu, it's 28 degrees without rain, for example. But when we talk about climate, it is the average weather condition in a place over a long time. So for example, the average weather in September in Vanuatu is 27 degrees. And the rainfall is 3 millimeters per day. But not necessarily that today we'll get that 3 millimeters per day. So in this case, I would like to stress that our work is related with climate, not weather. Also, we have to be mindful that there are a number of different time scales when we talk about weather and climate. So as I mentioned earlier, weather could be run for hours and days. Example is rainstorm and cyclone. And if it is month, it's become a season, wet, dry season, things like that. And the Bureau meteorology work is mostly on this sort of time scale, the season and the weather scales. So this is not at the scale that CSIRO work on. And then there is also what we call climate variability. This is the year-to-year different, last year will be different to this year, next year will be different to this year, something like that. And could be decade as well. A few decades ago, different to this decade, etc. And in the long term, it's what we call the climate change thing. And this is where our focus of work is. So I just would like to clarify that in the first place. Okay, so I hope that gives clarity to anyone. So now I'm moving toward to the brief presentation on the past and present climate in Vanuatu, just to give a context when we talk about the projection. So the first picture here showing you the rainfall and the temperature cycle in Vanuatu. The bar plot is showing you the rainfall. As you can see there is a marked distinctions. Wet season is from November to April, and dry season is from May to October. And in terms of the temperature, you can see the line there. The purple one is the maximum temperature, and the light blue is the mean temperature. As you can see, the coldest month would be around August, and the hottest month around January and December. Yep. Okay, so by the way, I forgot to mention, when I designed this presentation, I designed it in a way so that when I finish with the presentation, our partner in PMGD or sector or, Spread like Sunny and Maura can use this presentation because that's what usually being asked after the presentation for further outreach in Vanuatu. So what I mean by that is you will see lots of text in my slides, which usually I don't do, but for today's presentation, I put a lot of text so that hopefully it will be useful for those who would like to use this slide later on. That is just a intermezzo for that. Okay, next one is, of course, that one example is just for a particular place. And in terms of the whole Vanuatu, there is also special sort of variation in terms of the climate. On the left, it is the mean annual temperature. As you can see, there is different in one place to another. And the same for the rainfall as well. For the rainfall, for example, you can see it is influenced mostly by the location and the strength of the South Pacific Convergence Zone. So you can see there is a north to south sort of different in rainfall. You can also see that there is a topographical influence as well on the mean annual rainfall. So the next point that I would like to show is on the climate variability and trend according to the station data that we got from the Vanuatu Department of Meteorology through the Pacific portal. So the bar plot there showing the rainfall from 1950 to around 2019. If it is light blue, it's a year of El Nino. If it is dark blue, it is La Nina, for example. So in terms of rainfall, you can see there is a lot of variability, sort of, connecting to the El Nino, La Nino kind of thing. And there is no much clear evidence of trend in terms of rainfall. But if you look at the temperature, which is the red line there, there is relatively significant warming trends that we can see. And this particular one is for Port Vila, which is the capital city of Vanuatu. And then similar also a picture on another island, which is called Lamap. The rainfall is relatively very high variability, but the temperature shows some increase. By the way, I would like to let you know that some of the data is not homogenized. Some data is homogenized. So we put that information so that this is useful for your reference. So we did the same for several stations, and they gave us relatively the same message, basically. Rainfall very high variability, and less clear trend, but temperature, there is a trending trend, increasing trends for some station. So that is on a station based. Now I'm showing you some results if we are using grid data for the whole Vanuatu. This one is for temperature from around 1800 to around 2020, based on many grid data sets over here. And you can see there is sort of, of course, variability, high, low, high, low, high, low, etc. But you can see there is a sort of trending, especially in comparison to the baseline, which is this line. And the increase is faster in recent decades. And this data is including ocean, not just the inland of Vanuatu. In terms of rainfall, there's not much clear significant trend, whether decreasing or increasing. As you can see, the variability is so high, and there is a difference between different type of data. So the key message here is for rainfall, no significant trends, and which is consistent to the result that based on station that I showed earlier. Okay, so after learning about the past and present climate, we are now moving toward to climate projection. But before that, I will just pause for 1 second or 2 seconds or 1 minute. If there is any quick question or clarification required, things like that. No? Hello? All right. So nothing, no, yes?
Okay, we have a question here, Dewi.
Okay, thank you.
I'm interested on the last, in the current slide.
This one?
On the.
This one?
The
Which one?
slide number 12.
Oh, slide number 12. Okay, this one, yes.
I'm interested about the key message. So there is not significant trend. Can you further elaborate?
Okay. Okay, all right. So this is annual rainfall across the whole Vanuatu. Remember the map that I showed in an earlier slide? So the whole Vanuatu, including the ocean as well. So not just the inland of Vanuatu. Basically, it shows the rainfall from 1978 to 2020. So it is about 40 years based on the gridded data, not based on station data. So there are 3 gridded data that we are using here. And basically it shows that the annual rainfall can be very largely for 1 year to another. So for example, it could be from 1,400, $1,800, for example. So basically, it's very high variability. And you cannot see any trend, you know, whether it is increase or whether it is decrease, you cannot see. Unlike to temperature, for example, where you can clearly sort of, you know, increasing. For rainfall, we cannot see that trend, basically. So that is the key message from this sort of result. So I hope that answer your question.
Dewi, while we're on this slide, it's Sunny here.
Yes.
I think your key message is really loud and clear that inter-annual variability for Vanuatu, when you look at the global data sets that you show on this slide, makes it very difficult to determine whether next year will be, you know, a winter year. So you can see from the variability that it's difficult to project whether it will be, you know, if you're experiencing a dry year this year, it's really difficult for us to know that the next year will be, you know, whether it will be a winter year or a drier year, simply by looking at the oscillation of this graph going up and down.
Mm-hmm.
Would that be a good conclusion to make?
Yeah, but this one is for the whole Vanuatu, Sunny. And the one that we can also use is the station data that I showed earlier. And also, I think the Bureau of Meteorology part of the work in Vancirap is developing sort of seasonal forecasts. So, you know, Linda and colleague could give some information on that if it is a short-term sort of, you know, forecast. Because as I mentioned, CSIRO work is more toward the long-term sort of, you know, 30 years from now, 50 years from now, rather than next year or 2 years, something like that. Yeah. So Yuri will be the best person also to ask in terms of seasonal forecast. Maybe Linda can chip in if you like, please, Linda.
Hi. Yeah, I think I don't tend to work in that space so much. I'm more traditional knowledge. So yes, somebody else from the Bureau would be better placed.
Mm-hmm. Yeah. Yeah. Thank you. Okay. So can I move on now?
One more, Dewi.
Okay.
Slide quickly.
Yes.
That slide talks about the temperature increase from, I think, the pre-industrial period all the way now to about 1 degree, this particular slide.
Yes, yes.
Now, I think this slide is very good because when Vanuatu and other countries in the Pacific are negotiating at the COP,
yes,
we already see that the temperature is already sitting at 1 degree Celsius from the baseline, which is 1850 to 1900.
Mm-hmm. Mm-hmm.
We're just 1.5 degrees away from achieving 1.5, correct?
Yeah. So in terms of the increase, it will depend on the baseline we use. And for that, I got another slide, but I will not showing it here. But I have already showed it when we had the technical work group meeting. So in terms of the increase, whether it's 1 degree or 0.7, it will be depend on the baseline that we use. But anyhow, I will present that in a few slides after this, Sunny. I will touch base on the potential use of the information from our work to help the government for COP26, for example. Yes, I will show you something later on. Yeah. Okay. Yep.
Thank you, Dewi.
Okay, thanks. So I move on, yes?
Yes.
Okay, thanks, Maura. All right, so I now moving to climate projection. So we learned about what has been observed, what has been known. Now we are talking about what will be in the future. Something is not known because we will not know what will happen in the future. So before I'm talking about the result, I would like to make a note here. so that we will have some similar understanding. So when we talk about the projection, it is important to note that any future situation will depend on many things. In that case, there is always some element of uncertainty. We cannot really 100% sure that, 30 years from now, there will be no rain, for example, in Vanuatu, because there are many things that make the future happening. So in this case also, I would like to make notes that projection is usually shown as a range, not just one number. And this is important to note because many user or many stakeholder usually think that if we project something in the future, they ask give me just one number, for example, and that is impossible because I said earlier that any future situation will depend on many things. So to explain this concept further, I would like to give you an example using a house price in Vanuatu, for example. So in 2020s, maybe the middle value or the median price in Vanuatu of the house is 100,000 Fatu, but there is just a middle value. There could be range from 33 to 50, depending on the type of the house, how big it is, what is the location and things like that. So the same thing, if you would like to project the house price by 2015, you will not know how much the price of there by 2050. It would be just, you can estimate maybe the middle value would be 65 instead of 4,200,000. But you still have the range, which is the low and high. In this case, for example, between 55 to 80. And which one the price, we will never know. It could be just 60, it could be 79 or something like that. So the same thing when we talk about climate. So climate in 2020s, for example, okay, it's 28 degrees usually in Vanuatu. But by 2050s, it could be the middle value could be 28.4 degree, but it can range from 28.2 to 29.5 degree. So what I'm trying to show here is when we show projection, we usually using the middle value of range of possibilities. Here is the median, and we use the 10 and 90th percentile to show the range. So please note this one because that's how we usually present our projection. And you will see many things here from the slide after this. So I hope this gives you a bit of understanding about how projection usually being conducted. Now I will talk about the climate projection that we develop. We consider at least two things. The first one is how the world is going with its greenhouse gas emission. And we are still using the 3 RCP scenarios, which being used by the previous IPCC report. We are not using the current IPCC report because the timing of the work doesn't allow for us to do that. So 8.5 is the high, 6.0 is the medium one kind, and then 2.6 is low, and you can see how the projected CO2 emission, for example, here. And in terms of the global warming, the 8.5 giving you the highest global warming, and RCP 2.6 will be giving you the lowest sort of global warming. So that is the first consideration. The second consideration is how sensitive is Vanuatu climate to this change, to whatever happening in the world, whether Vanuatu sensitive to that. To assess that, we firstly using simulation from 40 global climate model, 45 actually. I put it more than 40 here. And then secondly, we also analyze simulation using high resolution client model called CCAM with input from 5 GCM. So today's presentation, I will show you some result from the GCM. I also show you some result from the CCAM thing. Okay, so let's start with the some example of the result from GCM. To do that, I will just explain a bit first. So this is a modeled temperature anomaly from 1900 to 2000 according one model, which is called CSM4. And it shows an anomaly so that we will know whether a particular point is above or below the baseline. So for this particular model, you can see that, you know, from 1900 to 2000, it's relatively close to the baseline. But after sort of 2000, it's increasing there. So this is just from one model. And I said earlier, we have 45 models, and we combine together, you will see like a scribble like this. So in this case, we sort of calculate the middle one or the median, say something like this. And then we calculate the bottom or 10 percentile, as I said earlier, as well as the top 90th percentile. So by having this sort of calculation, then we will show sort of a simple graph. In the past, this is the simulation of 45 model. And in the future, if we are using RCP 0.5 emission scenarios, this is what the result from the all 45 model. And if we put together, along with an example of the one model here, and this is the end result of the projection. So after knowing this, then I'll show you the result for Vanuatu North. Vanuatu North for RCP 8.5 for temperature will look like this. Basically, there is a sharp increase after around 2000. For 45, there is increase, but not as much. For 26, yeah, there is, but after that, there is a sort of flat down here. So I wrote down here that projected increase will depend on the emission scenarios that we are using. So that is the result for Vanuatu North. We got the same for Vanuatu Central, relatively similar, and the same for Vanuatu South. So in this case, some of the key message here is there's no clear difference between sub-region for annual temperature. Okay, now I move toward the same thing, but to show annual rainfall. And this is what happened with the annual rainfall. Remember earlier I showed the observed rainfall having a very high variability, and the model showing the same exactly thing. So there is a very high rainfall variability from one year to another. So there is no significant projected change, basically, according to the 45 model, be it RCP 8.5, 44.5, or 2.6, relatively the same. In this case, some models showing increase, some model showing decreases. So the spread is very big, basically. And as I said, there is a very large variability. So it is very difficult to get the clear understanding about the trend in the future. And the same thing for Vanuatu Central and Vanuatu South. Okay, and that is for annual rainfall. Now I'm showing you some result for the seasonal rainfall, not in a figure, but showing it in a summary table, just to give a flavor that we don't just produce figure, but we will also deliver a summary table. And this is an example of the summary table for projection for seasonal rainfall. So in this case, this is the future year, 2030 to 2090. And this is the emission scenarios for Vanuatu North, Central and South, for wet season, dry season, etc. So again, the projected change range from decrease to increase and could be very wide, could be from -12 to plus 5.1, for example. And the range of projection for dry season is usually greater than for the wet season, simply because, the dry season rainfall is small. So you are comparing relative to small baseline. So for example, by 2090, for wet season, there is a possibility to get decreased by 18%, but also possibility for increase in 18%. But for dry season, it's much larger, between -33 to 25. Okay, now those just example the result from the GCM. Now I'm showing you some result from the CSIRO downscale simulation, which has 50 kilometer spatial resolution. As I mentioned earlier, projection sometimes shown in a medium or middle thing. So this is the map of the whole Vanuatu projected change in mean temperature by 2030 for annual, for wet season, and for dry season. And this is all increasing from around 0.5. And the increase is projected everywhere. And but there is also the range here. The range is increased but smaller. But the larger range, it's projecting a larger one. So that's 2030. And by 2090, you will got more red here, meaning that by 2090, the projected change could be around, 2.9, 3.2, depending on the color here. So this is the result from the downscaling project that we got. In terms of rainfall, the same thing. This is the median for 2030. The multi-median project, no change, except maybe a bit around northwest region here, where it shows some blue color, meaning increase. But the lowest range suggests increasing. There is a potential of decreasing rainfall for all the season. But the higher or the 90th percentile showing potential for increase as well. So again, there is no clarity because the range can be decreased, it could be increased. But if we are looking at the middle value, the likelihood is will be increasing by 2030. In 2090, it seems to be dominated by the blue color. So weather is much more possibility for 2090 rather than being drier. Yeah, so that is sort of the key message. So again, all of the result is consistent with the GCM result, consistent with what we have observed in the station-based data, as well as in the predate data set. Okay, so the modeling and the observation relatively consistent to each other, which is a good outcome. Yeah. This particular slide, I'm showing you the projection for extreme temperature. And in this case, based on the CCAM result, extreme daily maximum temperature will be increased. For example, by 2030, it will be increased from 0.4 to 1.2 degree. For 2090, the increase could be around 1 degree to 1.7 degree. So this is the 20-year written value of the daily maximum temperature, and which is mostly important for agriculture, could be for tourism as well as for infrastructure. Yeah. So that is just a snapshot or several results that I showed. Maybe before I'm moving toward to the next discussion, which is how we can use this information, I will stop again in case there is any burning question or seeking clarification.
Dewi, Sunny here again. Sorry
Yes.
for the questions. Quickly, I just wanted to say that the way that the projections are presented, looking at 2030, 2050, 2070, 2090, I think works really well for us. In the sense that the current National Sustainable Development Plan for Vanuatu will complete by 2030. And I think the way that your projections are done, looking ahead beyond 2030, I think it will be useful for the government and us, who are policy makers, charting the way for Vanuatu after the 2030, the People's Plan. So I think your presentation today with 2030 projections really gives us an idea of what the temperature, what the rainfall will be like, say in the next, from now until 2030, which is the current implementation phase of Vanuatu's National Sustainable Management Plan. We're almost halfway through that period from 2016 to 2030. I think the projections will really help us understand what are the changes, projected changes from now until 2030, so that we can either adjust the delivery rate of our development agenda, but also looking further ahead beyond the 2030 plan and start discussing now, because we are moving into midway of our current implementation phase for the plan, but we also need to look beyond 2030. And I think I really appreciate this information because it will be useful. Okay. I have another comment in relation to moving this information upward to Parliament and the Council of Ministers. There's a strong appetite for that to happen.
Yep.
For them to also understand these very important scientific findings. And I appreciate you so much for the information. Some very interesting findings so far. But I'll leave it here. I'm noting the time.
Okay, thank you, Sunny. I think after this presentation, you know, I will transfer this into PDF or something like that, which you can use for your further outreach out there. And I said at the beginning, I designed this slide with plenty of text so that you can read it by yourself as well. Yeah. When I said you, it doesn't mean just you, but the whole VMGT and sector and things like that. So thank you. And we are happy to work with you if there is a need to give brief to the parliament or things like that. Very happy to work with you together on this because we would like to ensure that our products is being used for the benefit of Vanuatu, of course. Yeah, thank you. Okay, yes.
I have a question.
Yes, yes.
Thank you very much for this work that you have done in providing projection based on data from Vanuatu. My question is, referring back to when we had discussions regarding the Vanuatu region about the projections that you were going to develop, and we suggested that the projections be made, provided for the 3 different regions. From your expert perspective, was this, I can see that the analysis here showed like a little variation or change between the regions. Was this something that you had expected, like given the magnitude or the scale of the islands of Vanuatu? And Or was that, is this because of that, or is it
Okay.
because, yeah,
Yep. All
like
right.
little data we have, like,
Yeah.
yeah.
Okay. Yeah. So the projected change, the Bloom plot, that one, and the table and things like that. So far is the one based on the GCM, and GCM, as you know, have a very coarse resolution, like 100 to 200 kilometer, for example. So Vanuatu will be only having like 10 or 15 cells, grid cells. So that's why there is slightly less different between north, central, and south. But now we already have the result from the downscaled result, which is 50 kilometer. And we have the number, but we haven't had a chance to do the plotting. So based on the map that I showed you earlier, there is a slight difference between the north, central, and the south. So if we are using the downscaled simulation, there could be some additional value in terms of more difference between subregion. Moira, yeah. And even if there is no big difference, then that's okay. But that information can be used for specific region, just like when the stakeholder asking us to do subregion, then they can use, for example, okay, when they talk to Vanuatu North, they are using graph for Vanuatu North rather than Vanuatu, for example. So that in itself, it's still useful as well. Yeah.
Thank you very much, David.
Okay. All right. So I can move on?
Yes.
Okay. All right. So next part is just to give you some idea on how we can use this sort of information. So Sunny already mentioned a few things, and Moira already mentioned a few things, but I will show you, for example, the first slide that I show you is here is the projected change if the world is 1.5 degree, for example. So the temperature in Vanuatu will change more than 1 degree if we are using the baseline of 1850 to 1900. So this is answering your earlier question, Sunny. But if we are using the baseline of recent year, which is 86 2005, then Vanuatu will increase around 5 or 7 in 1.5 degree world. So I hope this is answer your question, Sunny. And if it is 2 degree world, this is what will happen in Vanuatu. So hopefully this sort of information can be used by national government in COP or international negotiation activity. And we also have the same result for rainfall, but today I'm just showing you the temperature change. Okay, so that is the first potential use of this information. Another potential use is, I've been showing this previously, but I'm showing it again just in case for those who haven't seen it. So we can use it, for example, to assess the agroclimate suitability. In this case, for Kava, for example. This is the current climate suitability if we are using temperature for Kava. Yellow meaning too warm, green meaning suitable. This is the present, and this is the future, or 2050, if we are using one model, GIS here. So as you can see, there is a slight difference. For example, this particular area becoming a bit too warm on the coastline. And I blew up the Santo Island. There is a difference between the future and present, especially on this particular area as well. So if we are using information from different model, similar message, but slightly different because this model is much hotter. So there is much area that becoming decreasing suitability for Kava. And again, for Santo Island here, less suitability around this area. So this is for Kava example, and I think Nathan and Stafford will show you how to use this sort of information in the portal later on. Now I'm showing you about to use the information to assess coffee suitability, for example. So this is a diagram showing the optimum condition of an area based on the annual rainfall and the annual temperature. If a particular area is in here, meaning they have optimum condition. But if it is here, then it will be marginal in terms of productivity. So I'm putting Tana, which is a central for coffee in Vanuatu. At the moment, Tana is located here. So it has optimum condition. So if there is a change, 1 degree in temperature and 10% in rainfall, Tana becoming like this here. So it will be still in an optimum condition. But for Evate, it can change from the marginal condition to not conditional for Evate. And for Pecoa, the same thing. Pecoa now is marginal condition, but in the future could be not suitable. So simple thing like this, you can using it again for briefing a Ministry of Agriculture or things like that. And you are welcome to speak with me or other team member to discuss this sort of thing. Another example is, again, I'm using agriculture sector for dry land taro here. So dry land taro have a cycle of planting around July to November, and then growth and development around October to November, and they harvest. And this is the rainfall currently, depending on the baseline that you use, whether 71 or 2000 or 81, 2010. And in the future, it will be look like this. So there will be more uncertainty around the growth and development cycle. It can be too wet, it could be too dry. So this could be another potential issue for management when people planting dry land taro, for example. Another example is for all sectors. We have some information about data that can be used to assess drought. So for example, this is a time series for Pecoa using one climate model. In historical, there is 7 extreme drought events from 1900 to 2005. But in the future, from until 2100, there is a 9 extreme drought event, meaning there is a potential increase in extreme drought events for this particular location, for this particular model. So we've got this sort of data, and we can share the range of uncertainty as well, but I don't show that today because of the time. All right, there is also benefit for VMGD and water sector, for example. Remember, I show you the climatology map, and this particular, I blew up the climatology for Santo Island, annual, wet season, and dry season. Could be used for designing monitoring network, for example. So at the moment, VMGD having a station over here, which is Pecoa Airport Rainfall Station. As you can see, it's actually representing the dry side of the island. So if we were to have a complete information, then there is a need more in station that represent for over other region. For example, the weather area here, for example. And the same thing for temperature. Pecoa Airport Station is located in the hot side of the place. So again, need more representation of the other climate regime, for example. And in terms of rainfall, I put the Sakata River here because I know Jonah wanting to have a station somewhere. So hopefully this map can help Jonah to decide to put the station. So at least you need to have one station here and one station there, because there are sort of 2 regimes of rainfall over here. So that could be another benefit of this information. And for all other sector, we can use all of this information for multi-criteria analysis. For example, combining information of rainfall, temperature, soil, farm management, etc. For example, for assessing suitability for CAFA complete. or soil erosion or other thing. And we will learn about that when there is a portal presentation this afternoon after us. So I think that's it. So I welcome any discussion before I'm moving toward the next one for Hemis. Yeah. Yes. Any question, feedback, suggestion? Moira, Sunny, and friends?
I think it's me, Sunny, again.
Yes.
I just wanted to reinforce my earlier point in relation to the next plan for the project to take the climate risk projections to the next level.
Mm-hmm.
We would appreciate if an executive summary, a high-level executive summary of the projections and the findings can be put together in a small brochure or small leaflet. It would be useful for us when we go out to the different departments doing our awareness and engagements with Parliament or the Council of Ministers. We are able to provide this, and I think there is some work already underway in that regard. But I think, let me say that from the project's perspective, thank you so much for the very interesting findings. We now know that no matter what we do, if we don't change our ways and convince our developed countries, temperature for Vanuatu will continue to rise, no matter what. So I think from that perspective, we should realign our development agenda for a warmer world that is hotter than today. And similarly with the other findings from rainfall, we will hear tropical cycle. I think, thank you so much for the very interesting presentation and findings. We look forward to taking the findings to our superiors, to our political leaders, so that they themselves will give us the guidance. Where will Vanuatu and the different departments move towards ending the implementation of the 2030 People's Plan, but also charting our development journey beyond the 2030. So I think I'll leave it there, but thank you so much again to Jeff and